Okay, go.
Okay, here we go. I'd like to welcome everybody here today. This is the Sustainable Fleet Technology webinar series. This is session number 2 for 2023, and it's medium duty, heavy duty charging infrastructure challenges and considerations. Medium and heavy duty is the hot topic lately. It's getting a lot of press. There's more and more options becoming available. Fleets are starting to do it. So let's learn how to do it and do it right, I guess. Would like to give a shout out and recognize our sponsors. We are, let's say, an underfunded organization, so we do rely on some of the activities we do to close the gap, and sponsors help it, and then some of our fee for service, as well as our conference. Top shelf companies working in the fleet industry, a variety of solutions. This whole way we're going to solve this is not one solution that fits all. It's a use all of the above, use all the tools available to you to achieve your goals, and these folks can help you do that. Format, if you've been on this before, is similar to what we've been doing for the last number of years. We'll hold Q&A to the end. We're on Zoom this year, so submit it to the chat, not panelists. This is a remnant from GoToWebinar. We're scheduled for 2 to 3:15. We're going to try and get our presentation done in less than 60 minutes and then have time for Q&A. There is a handout in a recording, and anybody that registered will get this. We'll get both of them. That's that. And then do want to let you know where to learn information about upcoming webinars as well as the conference, and that's at sustainablefleetexpo.com. We have past recordings and handouts from sessions going back a couple of years, so you can see what we've done in the past. We'll cover quite a variety of topics in the fleet industry, and then what we're doing this year and what's coming, as well as the conference. And as the conference, let's say, evolves and we have more information and speakers, we'll add more information to that. Again, sustainablefleetexpo.com. Here's our agenda for today. I'm Rick Sapienza. I'm gonna host this, and I'm doing the introduction. We're gonna have a little bit of a round table back and forth between Keith. Oh, so I'm sorry, I forgot to. We had a last minute substitution. It was Keith Dickerson, but it's Paul Steith with Black and Veatch and Jeremy Baksh with eTrans Energy. And then so substitute Paul in where Keith is in these two. And Paul's going to talk about some project planning and execution overview, things to consider and to watch out for. And then Jeremy has a couple project examples that they've worked on. There is, I've somewhat mentioned them, but here are our two speakers. Paul with Black and Veatch. He is the Associate Vice President of Global Transportation Initiatives. And then Jeremy Baksh is with eTrans Energy, which is a subsidiary of Duke Energy, and he's a project director. So he's been hands-on and done quite a variety of projects as well as Paul for that matter. So these guys are out there doing it. They've seen some of the issues and some of the, let's say, unintended consequences of potholes you can run into. And I'm going to let these guys go from there. Paul, I'm going to let you talk, introduce Black and Veatch just a little bit. I don't know if you had seen this slide. And Jeremy will do the same.
I have, and the fun thing about that slide is it's already inaccurate, right? Because things move on fast. So glad to join today. Paul Stith with Black and Veatch. I've been on board for 8 years this month, and I've had a variety of roles, but the mission is extremely similar throughout them. It's looking at anticipating the market, where is it going, how do we scale as Black and Veatch to meet the needs. And it's pretty exciting because our toolbox includes the utility side, the grid side, very large solar renewable projects, all the way through to this expertise we're talking about today, which is in medium heavy duty fleets and depots. We have been active in this in transit and some of the earliest programs for several years. So again, the numbers already are well over 2,000, and here we are 108 years already.
All right, great. Thank you, Paul. And then for eTrans Energy, Jeremy.
Hey, so good afternoon. I think our goal is sort of summed up in the middle, right? We want to accelerate electrification. So we are a wholly owned subsidiary of Duke Energy. So we want to deploy infrastructure. We sort of gravitate to our natural footprint in the Carolinas and Florida and Indiana. but we are geared towards helping private fleet customers electrify. So a lot of national clients are located within our footprint. We help those. And as we are a commercial entity, we can sort of leave the regulated footprint and move beyond that. Our mandate, again, is to accelerate electrification. We're deploying infrastructure. We're focused on energy management and also zero emission energy. So as fleets electrify, they look at resiliency options, they look to backup generation, they look to solar, they look to energy management. We want to be a player in that space and help our private fleets.
Great. Okay, so as we look at, the challenge here of the projects, I mean, there's a couple areas that you need to focus on. One is the equipment itself. The other is the facility and its electrical infrastructure to support that equipment. And then the utility service infrastructure to get you the power you need. And then, potentially distributed energy sources off grid in case there is an interruption to keep your fleet rolling. And we're going to have both Jeremy and Paul talk about some of the things you need to be aware of and pay attention to. So Jeremy, I'm going to let you lead off. You can, we don't have to go exactly with all these bullet points, but I think we just want to do it back and forth and talk about some experiences you've had with each, maybe.
Sure, I'll lead off, Paul, and then we can go sort of give and take here. But I think one of the things we've seen, and we'll start off with sort of EVSE, and I'll touch on the vehicle ratio in a second, but the technology is moving. It's moving very quickly. This is still a somewhat nascent technology market. There are a lot of providers out there. But I think it's important for fleet operators to understand the product that they're buying. And if I could go one step further, it's sort of my time at Duke Energy. When you start to deploy EVSE infrastructure, chargers per se, you end up with a fleet of electrical equipment. So you've got your fleet that you're electrifying, but you will have a fleet of equipment at some point. And we encourage operators to think to that fleet concept, not just for the vehicle, but for the EVSE as well. If you try to go for low-cost providers, you may end up with a hodgepodge of OEMs on your property. And that may be sort of cost beneficial, but is that a long-term benefit to an operator if they have EVSEs of sort of all styles and flavors on the property? You may want to think about standardization. I think operators today are very good at looking at the vehicle parameters, trying to understand which vehicles sort of will fit their need as they electrify. And we try to tell folks, you've got to have that same air to the EVSE infrastructure. And Paul, I was going to pause there to get your take, but I don't want to sort of go too long.
Yeah, I think that you hit on some really important things. We're also seeing, and you've got this last bullet, which is actually huge, is the future optionality, right? So the EVSE that you're describing and getting some standards in place, getting some consistency is super important. At the same time, realize that the power infrastructure is those EVSE may be swapped out in five years or some number like that. The 20 plus year investments are happening with switchgear, with where transformers and land use, where you're going to put space for these on site for today. And then as in fact your fleet grows in its electrification footprint, how do you make sure you take account for that and this whole least regrets investment, but also provisioning in a way you might need to overspend, particularly in switchgear and the space for the transformer, come back later to put a larger transformer. Or we see an awful lot today of fleets that will get over 2+ megawatts, 3, 4, and beyond, and they need to be very thoughtful about the potential of primary service on their site and what that'll look like. And again, those are big design considerations for sure.
If I could touch on vehicle parameters to sort of follow the design considerations, I think here it's also important to look at the fact that you cannot give your vehicle any more than it can accept. And by that, I mean, if we were to take an example of a standard fleet type, for us, we've got a lot of customers that look at the Ford E-Transit. That vehicle has an 11.5 kW inverter. So if we were to think about charging that at level 2, Even if we had a higher rated level 2 charger, it would only charge as fast as the inverter would allow. So I think folks have to really understand the battery parameters, but also the inverter parameters to align to whatever level 2 charging they're doing. There's also a limitation on the DC fast charger side of we've seen. Again, looking at the e-Transit from a vehicle standpoint, we understand that vehicle to be limited to 115 kW fast charger. So a little bit of future proofing to some of Paul's comment about switchgear. If we think about the e-Transit and its deployment, it can only accept 11.5 at a level 2 charge. It can only accept 115 kW at a fast charge. But operators need to take into account parameters today, but parameters going forward. I'm not a Ford employee, but I think Ford will make advancements with the e-Transit, and it's likely that inverter size will move up. They will move up to accept higher DC fast chargers. So you do want to make that sort of future investment today the best you can. And I agree with Paul's comment that switchgear, that electrical infrastructure, having to go into a fleet depot and cut asphalt and put in conduits, that's something you really want to do one time or plan for methodically as you build out. So I'm kind of bleeding over in a physical configuration here a little bit, but as you build out your electrification plan, think about opening up your operations in a limited scale. But then as you phase into it, you may want to go ahead and make some investments in that physical infrastructure from the get-go.
I think we're going to touch on, there's a charging power sheet that we'll kind of hover on, where an important consideration is actually the cost of wire and how far you're running it. And so in fact, if you consider, and we are seeing this, there's a pivot point to economics around low power DC charging, because you can then supply those EVSE with 480 voltage, which may already be on site. You don't have to step it down, or maybe part of the design, so that you don't have to do step down transformers throughout a depot, a large depot that is. And the cost of the wire, because you're running higher voltage, is actually to be offset by what could be a little higher cost EVSE. So there's some really interesting things that back to the vehicle, its capabilities, what the vehicle will be in the future, and then some honest look at the costs of the different hardscape, call it, the wire and the conduit, that add up quickly when you're talking about dozens, or we've seen depots with 300-400 vehicles. It gets kind of crazy because you're going to go long distances.
Yeah, I think to touch on sort of EVSE vehicle ratio a little bit, we have seen folks sort of take the approach that if you've got a long dwell time, if you've got 8 to 10 hours, because your vehicles will sort of sleep at the depot and be ready at 6 a.m. the next day, level 2 charging tends to work fine for that, even with the inverter limitations perhaps on the vehicle. But you may want to invest in a fast charger to buy yourself some resiliency, or perhaps an emergency situation if for some reason the operator failed to plug in the port correctly and the vehicle did not charge. So specifically on vehicle ratio, it sort of varies by customer and customer need as we've seen it. But we've seen folks look at anywhere from a 5-to-1 ratio, depending on their route profile and their operations, or even a 40-to-1. And it's more in favor of level 2 charging to keep the costs down. They know how to manage their fleets. They have these long dwell times, but then recognizing that the fast charger has a place. As we step into medium duty and heavy duty vehicles, level 2s will play less of a role, and you'll have to look at fast charging. And we don't address it on the slides, but we think about sequential versus simultaneous charging. And if you have a fast charger that's capable of simultaneous charging, you're obviously going to split the power output of that charger amongst the connected vehicles that it can support. But perhaps sequential charging for your medium duty, heavy duty fleets might be an option, because you can cycle through charging of those vehicles at full power, depending on the state of charge when they return to the depot.
No, some good points there on that one. We've seen some mistakes, and you need to pay attention to that. Do we want to go ahead and move on to the facility itself?
Sure.
All right. Oh, well, before we go, you guys were talking about, the levels. I mean, the point here is, I mean, these are larger vehicles, they're carrying more payload. They need more energy storage to do their job. And we're seeing, this is some real quick stuff looking at what some of they had. You're seeing anywhere from 100 kWh to almost 3/4 of a megawatt per vehicle. So when you have multiple vehicles, Paul had mentioned, 2, 3, 5 megawatt requirements. You're in the megawatt range. And then in terms of, people ask you, what's the range of the vehicle? There's been a number of studies out there, and I didn't have trash truck. I was able to find school bus, some class 8s, and transit. And it was interesting. CalSTART, Texas A&M Transportation, MACV, some others, NREL, and they all come up with an average around about 2 kilowatts per mile. And the ranges in some of the studies showed 1.5 to 2.9. And it's dependent on the load, the terrain, et cetera. It can really change. But so you could have, unless you're high powered DC fast, you could have some significant dwell times to get the power you need to do your job, is the point here. And then I'll let Paul and Jeremy talk about the charging level 1, 2 DC fast and beyond.
So one of the things, so transit is a very important, and depending on that transit agency, they may have more dwell time, or they could be a little bit more like, say, New York City, where they need to operate 20 some hours a day, right? So that very much depends. I think the thing, and talk about numbers and moving forward, right? So we're very active in the megawatt charging sphere, where the power levels will go up even higher. 1.2 megawatts could become common for chargers on the go, but also shared assets in a depot where that power recovery is needed in order for the truck to get back on the road to do the job. And the money of that truck is not for it to be parked, but rather for it to be moving. So the battery sizes, 3/4 of a megawatt up to a megawatt, are starting to appear in heavy duty trucks today. So the refill times, do need to go up. The Charin system, and I've been part of that working group for since 2018. It's actually capable of 3.7 megawatts of charge to one vehicle, 3,000 amps, 1,250 volts is the limit on it right now. In the mining group are going even higher than that. So I think it's a lot about economics, those vehicles, and what's their return to service look like, and how might you share. I saw questions about the charger ratio. We do believe there'll be a blend of lower power and higher power at sites. In fact, most of our designs today are kind of accounting for putting a placeholder for megawatt charging to augment slow charging, which is 150 kilowatts for big trucks.
Yeah, Rick, you've got the charge power slide up here, and I just, to echo Paul's comments, I think we will see a mixed bag of sort of low power level 2 charging, perhaps low power DC fast charging. You've got the 50 kW mark on there. For us, DC fast charging sort of starts at 24 kW. Your previous slide had a picture of a school bus, and we've seen that 24 kW, given the dwell times of a school bus, can be perfectly sufficient for that bus and allow the bus to recharge and run its route the next day. Just as a general comment, I think level 1 for large fleets is not an option. I understand the definition of level 1, but that's certainly something that needs to be wiped off the board. Level 2, you are limited by your inverter. But I think folks need to plan for the higher output level 2, because that technology will advance on the vehicle side. And then with the fast chargers, medium heavy duty fleets, they are going to be fast charger dependent for the most part. And that's when, to Paul's comment, when you get into the megawatt charging, you become essentially an energy operator, right? You could have several megawatts of energy on your facility, and you're not going to have to manage that energy more efficiently. How you use it in tandem with your utility, and perhaps your time of use rates that you have. So that's going to be a big concern. I think folks need to think and plan for. Chargers are a bit of a commodity. I think The list of folks that supply chargers and charging hardware is very long, and it'll probably get longer, but you do have a lot of options to choose from.
Okay, good. Now, sorry about that. Now we'll talk about the facility. So, yeah, you need to understand what
I'll lead on that one. If you know, let's start with a base case. Like, what kind of a facility is it today, right? If it is a warehouse with just some LED retrofit lights, the entire warehouse would be, you know, a few hundred kilowatts maximum. If it's a food, beverage, or cold pack storage, they actually already understand what a 3,000 amp panel looks like. So when you have that facility, and I also noticed in chat when somebody's saying, gosh, we don't even have, you know, 3-phase power at our building. Well, the news is if you're going to support these types of service vehicles at a depot facility, you very likely will be bringing new service, and that new service is going to terminate on 480 or perhaps medium voltage, depending on the requirements. So that's something we see, that if you're thinking you're going to be able to power your vehicles from your current electric infrastructure, at a certain point, like about 1 or 2 vehicles, then honestly, it's not viable. You need to look at how you'll bring more power. You also need to be thoughtful about the cost to integrate your existing building into that new power. Call it repowering the building. Well, you bring in another megawatt or 2, whatever that is, and you need to feed your building. It's actually kind of expensive to do that. So having 2 services on site, if it's allowed, is often more economic. It also allows you to take advantage if there are EV programs that don't support building loads, then you're in a position to you know, put those there. Caveats: if you want energy storage, you want to integrate solar on site, those things are going to be something that, of course, are part of all these choices about what does your facility look like? Does it have a big roof already? Do you already have solar? Many different things.
Yeah, just to add to that, Paul, I think the transition won't happen all at once. It'll be likely phased in. So as you look to blend electric vehicles into your ICE fleet, that's a consideration that you're going to have to manage through. Folks today aren't going to make the investment to go fully electric at perhaps a distribution center or a depot, but they are going to pilot electric vehicles. So obviously, where you locate that charging infrastructure needs to be conducive to your operations, but there is going to be impact to your operations as you sort of live with the EVs co-located with your ICE fleets. You know, to add on to Paul's comments about building upgrades and sort of additional infrastructure, I think folks are looking to say, if we're going to make the investment into battery electric vehicles, we likely want a roadmap to on-site solar generation or perhaps battery storage at some point to offset our usage and to address the utility rate tariff implications by bringing down those demand charges. So you do have to have this foresight and planning, plan for your ultimate build out at your facilities, because those are issues that you need to account for sort of today as you plan for those ultimate rollouts.
So something else that I'll just tag onto that, by chance, if you're planning a new facility, this is the moment to get involved with what electrification is going to look like in the future at that facility, be it the service entrance, even provisioning just the space. And you know, if you happen to be digging a trench, putting extra conduit is so inexpensive compared to doing it later. So for organizations that do have a portfolio of existing and future planned, that's something definitely to get involved with your facilities team and make sure that they understand the costs of doing these things later versus getting involved today. It might slow back your design a little bit, but it is going to pay back considerably by understanding and how you can plan for that infrastructure.
Yeah, one more point, Rick, if I could add on the charge management options. That is a big deal for folks. They want to be able to understand the energy the vehicles are using, understand when they can charge or when they should charge if they have the option with longer dwell times, depending on the current or future rate tariff implications. But interoperability is a big deal I think operators need to look at. And when I say interoperability, it's not just a physical charger interface, but it's sort of charge management in tandem with perhaps your telematics system that you have for your fleet. You know, that you're going to tie together software in so many fronts. So your charge management software is going to manage charging your vehicles. But if you have telematics that sends telemetry when those vehicles are out on the road, you want to be able to integrate that into your system and have all of these sort of software tools talk to each other effectively and provide your fleet operator sort of actionable information. So that is a topic I think we see folks sort of underestimate because they have a fleet telematics system today, but you've got to plan for how that battery electric vehicle integrates into that system, along with the charge management that you're going to be relying on to manage that vehicle's charging.
Very good point. That's important, and that's how fleets are run today. It is by the numbers. There's a lot of data out there, and it needs to be integrated to help make a decision. Oop. All right. So the last part of this, well, not the last, but the next part is the utility and getting the power to your building. Considerations there. And I think we've kind of touched on a little bit of it, but I'll let you guys go.
Yeah, and Paul, I'll just jump in here for a second here. I think I did notice a question in the chat about lead times. I don't know if I read it correctly, but I think before folks try to get in gear with electrification and battery electric vehicles, you've got to understand that utility piece where you perhaps are located. It's sort of different nationwide as we've seen it trying to help customers electrify, but certainly a conversation with your utility provider is going to be tantamount to helping you understand lead times, capacities, and thresholds. If you want to deploy a fleet of medium duty or heavy duty tractors that are going to be in the 0.5 megawatt to a megawatt range in terms of battery size, that's going to be a significant power load for the utility. And they may or may not be able to meet that power load today. It could take, I think there's a slide in here, 24 to 48 months. And if you have vehicles on order, you definitely want to understand what that time frame is for the utility.
No, I agree. We had a logistics provider looked at 75 sites, and there were only 5 of them, and 2 happened to be across the street from each other. So it got them down to 4. All the other sites, it was a minimum of 2 years to get the power they needed to charge some stuff. So it really changed their plans quite a bit.
Yeah, this is just a fundamental part of all fleet electrification considerations. There's no substitute for doing due diligence on your portfolio of sites. Every grid, you can have cookie cutter buildings the same in all these different regions, but you will, check my words, but you will never have the same grid conditions at any 2 facilities. That feeder is going to be unique. It'll be different, potentially voltage and capacity. The poles that come from the substation may or may not support additional feeders. The resilience of that circuit, there is nothing ever going to be the same. What will be the same and guaranteed is if you don't get that power, then very likely if you're in an industrial area, your neighbors want to claim that power. So the thing that we really all need to do, and I was just at a big meeting yesterday with lots of fleets, is start to share that data early and often, but also acknowledge the way that the utility load request process works is there's a queue, and you need to be prepared with a strong technical document that goes in single line drawings and your plan today and in the future that gets to that utility so they can appreciate your timelines. And then this 1, 2 years, 5 years, those things are real. In fact, if you need a new substation, it could be 7 to 10 years. I've seen some data with clusters of areas that have over 200 megawatts of new load coming based on the warehouses that are in a small cluster radius. So, that's like 3 to 5 substations that would be needed if we're going to, meet, our goals. So early and often communication, highly technical communication and relationships with the utilities. It's something we pride ourselves on, is being able to come with the engineering answers. And something really important, don't, be careful, right? Don't be asking for nameplate. You don't say, I have 100 trucks, 100 this or that, and it's all of a sudden 10 megawatts, when in fact you can do some offsets with smarter charging, with understanding your duty cycles, and perhaps, and this is an area of growth for sure, what other things you'll bring to offset the gap. You might be able to get 1 megawatt, but you need 2. What types of things can you fit on site that will bridge that gap? What technologies, what's their carbon intensity? Just energy storage filled off peak, not huge carbon intensities. Other generation sources, you have to put that into the calculus.
And just one thing to add there, I think if you look at the rate tariff options on this slide, that sort of bullet point, as your energy demand increases because of electrification, you need to be cognizant of your existing rate structure. If you don't have an electric fleet, and like Paul said, if you're just operating a small distribution center, your load is likely such that you're on a general service rate, and your cost of energy is low. As you leg into electrification and your demands grow, that tariff option is going to be super important. I think in some markets, electric markets, folks have the ability for retail choice, so they can shop for their energy. So that's something that folks definitely want to plan for, and plan for early. It's, how does electrification happen to you? How do your rate tariff options unfold? And how can you sort of manage the energy costs over time? Because depending on where you are, there may be different utility programs. Virtually most utilities have some sort of a make-ready credit now for electrification. So that's another avenue folks want to take advantage of. It's, sort of utilities contributing to your electrification journey by offsetting not 100% of your infrastructure costs, but hopefully a significant and measurable amount that helps you leg into electrification, because it is not cheap to deploy this infrastructure.
Okay, we're talking about distributed energy resources, and you guys had alluded to that already with some storage and some other types of generation, and why you do it. Why don't you go ahead and focus on it a little bit more?
Yeah, I think that it is driven by the unique circumstances of a specific location, a specific utility, the structure and available integration on that feeder, and with the financial side of it, right? So if there is solar and you have excess generation, but there's not a favorable tariff, then it makes less sense. Your trucks are going to be there possibly at night, not when solar is generating. So, do you need battery storage in order to make that equation work out, right? It's a big, set of inputs, include the capital cost of said assets, right? Everybody loves solar, but does it make sense as rooftop or canopies, which are quite expensive, or ground mount, which requires a whole bunch of space? And be realistic, right? A transit bus requires about an acre of solar a day when the sun is shining, but the bus isn't there, right? So how do you get honest about when that generation can be available, and how it can, contribute to the economics and to the clean energy quotient? Resilience, everybody wants a microgrid. When you find out what it takes to build one with the online and the ability to go offline and seamlessly come back online, it's kind of expensive. So you have to think about, what does resilience mean for your organization? It might just be a system that can go offline and maybe not, come back on in microseconds.
I think, Paul, sort of the bill on what you said, and I like your phrase, you need to be realistic with your objectives. I think folks may have somewhat of a jaded view based on hype and other PowerPoints that they've seen, that these technologies are at the ready. And they are at the ready, but they are at the ready at a significant cost. So you really need to be, to Paul's point, realistic on what your site needs are and what the economics of electrification are for your facility and for your fleet. Solar is definitely an option folks should consider, as is battery storage. But I think folks tend to look not so favorably on backup diesel generation, but diesel generation may be a solution to your resiliency issue if you have an all electric fleet and you don't have the space for solar and storage. So I think you have to be honest in terms of your operations. And to Paul's point, you definitely have to be realistic, not only to the cost, but to how you plan to phase into electrification over time.
Last point, even if you can get the cost and the engineering to work out, you do need to be aware of where the funding comes from and any additional constraints, right? So a utility tariff or a utility rebate may or may not be compatible with distributed energy resources. If you're in transit, for example, there may not be solutions that are Buy America compliant, right? So the school buses may have some of the similar constraints. So how you engineer it is one thing. How and where those funds come from to make up the economic gap are a real thing you have to be realistic about.
Yeah, no, good point, Paul, bringing up that Buy America. It did look like they're going to give waivers for charging infrastructure for a year to reevaluate it, even though a lot of it's new, as we've had about a 6-7 year, they weren't granting waivers. A lot of the manufacturers have been able to become Buy America compliant, but that is a consideration. It can bite you if you go down the path and then find out, oh, you're not compliant, so you're not eligible for the money. That's good. So moving on, Paul's gonna talk about some of the nuances and get a details overview on executing a project. So Paul, I'm gonna let you go ahead and go from here.
Let me just do a whirlwind, and I think we're going to end up. You'll see the way we approach these projects. It really is trying to be proactive as we go and remain, be realistic, right? And I don't know that everyone understands all the bits and pieces. So this is going to be a whirlwind tour of some of the behind the scenes secret sauce, if you will, of how these things emerge. And we're working on hundreds of sites simultaneously, so they benefit from our process. In cost savings and value engineering, again, you overbuild a site, you use the nameplates of the vehicles in order to say, we need XYZ. Well, right at the beginning, getting those operational constraints and put into it, and looking at, well, where does the power come on site? Concrete, conduit, and wire can become very expensive. Copper goes ups and downs. And it is really important to appreciate the physics, if you will, of higher power over thinner wires. It's a lot cheaper. So if you can actually put that at the edge of the property, that it happens to be near where the site is going to be doing its charging for the power cabinets for charging, or if it's AC charging. Kind of talked about that a little bit before as well. So it's layouts, it's many different things. And of course, you're going to need to take these plans forward to the authority having jurisdiction, the city, the county, or other authorities. We're doing a lot of work on airports right now, and that's just crazy because you have the airport authority in addition to all these things. And it does come down to detailed design so that you understand what's getting permitted. And throughout the construction process, as there are questions, ideally we're reducing the number of questions by having thorough designs. But there, if situations come up ad hoc, be it an undiscovered utility or whatnot. Let's move to the next slide. So in the layout phase, again, we find all sorts of things you might not be thinking about. Parking lots are often parking lots for a reason, because there is something else under it that you wouldn't want to build over. It could be rights of ways, could be the geography of a site. We've done and had to do some very interesting things about drainage. The larger a site, and if you come back in and touch a site, you may be finding things that you need to have, new considerations if you talk about compliance. With regard to ADA, if it is a public access site, many fleets, we need to be thoughtful about that, depending on their drivers and maintenance and technicians. In public, it becomes imperative that the ADA, American Disabilities Act, is part of that, right? How can people access these sites and take advantage of them? we're often going through steps in a process that start with like a site. Here is an initial layout, could be done just kind of in, call it PowerPoint or more engineered with the topography of the site when we've got our survey in place that will, understand, appreciate the elevation. Very frequently in public view, you're going to also have things like landscaping that you just really didn't think about until you touch a site, and it's going to become near under scrutiny for the new policies, or I call it a tree deficit or bush deficit. You might actually, as a facility, kind of owe some catch up. And what's going to happen during permitting is they're going to come through with things like, well, you owe us about 5 more trees if you're talking about a large campus or project. And that's just some things to be aware of. Fault current calculations, by the way, when you start putting more devices on a particular circuit breaker, you have to be super appreciative of those things that the devices can actually handle the fault current, and that jives with the rest of the engineered approach. Let's go next slide. Time. So time to get access to new power. It's, you don't just click your heels and it shows up. It's pretty rare that it's sitting right there at the street, at the property line, ready for you. Occasionally it happens, but not that often. And occasionally you'll have enough power in a facility that you could use the existing utility service and then branch off of that. It's pretty rare as we scale up beyond a few vehicles that that's the case. We're usually going to need either a service upgrade, or as talked about, it's often economic to establish a new service if you're able to do that. Mind you, it's going to take more space for that service to land. This is a chart that we've kind of worked at, vetted. I think we put this together in 2017 originally with our utility engineers. So, we work for the utility side as well. What does it really take? And these numbers kind of hold. What isn't on these are kind of some ideal numbers, are supply chain delays that we are seeing today for transformers, for the switchgear, for the chargers, right? So you cannot get your grid connection request forward or advanced without having the utility engineering piece of this done. So the utility design package and integrating that with your on-site plans. So be aware that as you are approaching sites, perhaps lots of them with different utilities, that you can't trigger the final let's go without your designs being done with the utility. And also you're going to fund, depending on the size of the site, you may be funding the preliminary engineering and final engineering from a utility in order to start the clock as to when they can deliver that power to your site. And then they need to schedule it, of course, with their resources that are going to do the final design. Utilities, people don't understand this. They also need to get permits often for their work. So as you're going through your process, they are as well. This is just some guidelines. In a case that we don't have a substation, that's where we add years to the quotient for the right-of-ways. And think about it. What does it take to pull a high new transmission into an urban or even a rural area? Let's go next slide. These are some numbers that could use some updating again, due to time and inflation and whatnot, but some ballparks. It's not uncommon for new feeders to have certain costs, new service entrance upgrades to have costs. How those costs are shared with the customers is something to be aware of in a commercial agreement with a utility for new electric service. There is oftentimes ability to kind of cost load that onto the future load in accordance with that. If you don't use that load, then you may have to pay back prices that might have been part of your agreement at the outset. Utility make-ready programs and other ways to offset these costs are really important. That they have programs that could bring pieces of this to the fold. There also could be new ways that you may kind of wrap these things together. So just be aware there are costs, and it will be borne by the overall ratepayers and by specific locations. And that's part of some of the ongoing discussion is, should the last fleet depot pay the load, the economic load for a neighborhood that needs serious upgrades? And that in regulatory frameworks, that's moving forward to find ways to socialize those costs, because you can't burden the last fleet for being the last fleet. Pretty important stuff going on in that space. Let's go to the next slide. Scheduling, talked about it. It's something that you must be hand in hand with your local utility and understand their process. So we've talked enough about that. These are just some of the items that are there that are going to need to be cared and fed. Who owns the meter? Who has the account? Who will be writing the checks in order to trigger these utility services? And then keeping very mindful of, again, their schedules and what a utility needs to do to bring power to a site. In a commercial zone, perhaps in a more public area, there could even be more considerations where the utility has to similarly look at landscaping and many other things, perhaps work with a DOT or a city if they need to tear up a street in order to bring power. Let's go ahead and go to the next slide. So I think that kind of covers sort of the power side of it. I've mentioned, trees and environmental type considerations. Those things are that the jurisdictions have a lot of control and power to maintain, safety and consistency in their jurisdictions. And some of them don't understand electrification, so this is kind of new to them. And others are starting to get. There's a lot of effort to streamline this, but again, it's so much new work coming through these departments that you have to be realistic and understand how to be a good customer and be complete and thorough with your application. This is something we pride ourselves on. We're doing lots of assets at once, and you need to understand that that's part of their workload that you're increasing, so you've got to make it as easy as possible for them. I think that's kind of a lot of the pointers that I can share, and let's roll the next slide.
Okay, so next up, we're gonna have Jeremy talk about specifics of a couple of projects they've worked on. And thank you, Paul, for that. That was really good. And Jeremy.
Sure. So here we've got a real world example of a depot. For this customer, we're actually deploying 48 level 2 chargers, 2 fast chargers. So it's not quite that 40-to-1 ratio, but this customer has long dwell times, so the vehicles do come back to the depot. They're sleeping in the depot 10 to 12 hours, but they do want to consider some element of backup and have the fast charger available. And here they've gone with 220 kW fast chargers with simultaneous charging. So if 2 vehicles are plugged in, each vehicle would get 60 kW and they would charge significantly faster compared to a level 2 charger. And I think we've touched on sort of a lot of the themes here, but we wanted to give an example of the costs associated with this. And Paul did a good job of sort of outlining the civil and electrical costs, talking about conduit, the fact that cables and wire are expensive. There is a significant lead time to that equipment. So it's not just the utility. We have seen switchgear lead times move from 52 weeks, in some cases out to 85 weeks. So that is a significant strain on the industry. But if we were to take a look at the costs here, you see that over 50% of the total project costs are really your site electrical and civil costs. So cutting the asphalt, putting down the cables, putting in the conduit, repatching that asphalt. And then there's an impact to the site operations. This depot needs to continue to deliver product while this work is taking place. So we have to be very methodical in how we go in and sort of cut up their parking lots to have the infrastructure in place for when the battery electric vehicles show up. Paul touched on sort of the engineering and planning aspects. There is some level of engineering and permitting that has to go along with these projects. Those are costs that need to be considered. At the end of the day, the charger costs are, in this example, less than 20%. So it's something to consider. You're having to, obviously, as an operator, consider the cost of the vehicle, which a battery electric variant could be twice as expensive as a gas variant. The chargers are certainly a significant cost that people have to incur, but site infrastructure, I can't stress enough, is very costly. And the more you plan for how this infrastructure gets laid out on your facility, you can start to impact that greater than 50% bar here that you see for site electrical and site civil. And we can go to the next slide, Rick. So I think, again, we've touched on this theme of power requirements. So here we looked at a site assessment for a very large distribution center, and they had over 125 over-the-road tractors, so class 7 and 8 vehicles. They have a significant amount of yard tractors, 10, and then this operator had refrigeration trailers on their property that they were also looking to electrify. Again, if we consider the ultimate build out of this yard, assuming 80% electrification, if we're looking at predominantly fast chargers and yard tractors, given the size of the vehicles, the size of the batteries, and perhaps shorter dwell times, because the over-the-road tractors need to turn, and like I think Paul said it, be back on the road moving product, you're looking at significant electrical loads for this facility. It was anywhere between 15 and 20 MVA, which I think Paul had a good slide that laid out the cost for that infrastructure. You're looking at tens of millions of dollars, and this infrastructure could not be ready today. It takes time to plan and to leg into. Paul made the comment, it is sort of rare for facilities to have usable capacity, but we have come across instances where folks have site capacity. In this case, this particular depot had about 3 MVA of capacity we could use to deploy charging so that they can leg into electrification. I think it's unrealistic for someone to believe that depots are going to electrify all at once today. It's going to be phased in, and it's going to be phased in over time because of the challenges that we're seeing, not just with cost and lead times, but with actually physically doing the work and getting the infrastructure to the site. Sites have to be laid out methodically. 15 to 20 MVA of capacity delivered to a facility, it's going to be very difficult to deliver that all to one spot. So you certainly want to carve up the site, understand how to lay out the switchgear, how to lay out your load centers and your charging, so your operations aren't adversely impacted by infrastructure as it's put into place. But then as your vehicles come in, they charge, they're obviously going to commingle with ICE vehicles to begin with. And I think I've made that point several times. You've got to be able to plan for that and forecast how that impacts your operations. And that's really it, Rick. I think we've touched on a lot of this before.
No, that's good. Well, thank you, Jeremy. Thank you, Paul. Now that's about it for presentation wise. And I guess we lived up to our promise in doing it in less than 60 minutes. So that's good. And we'll go ahead and open up the chat and see what we have for questions here. I think you guys are peeking at it to begin with. I think in this discussion, you talked about the 40-to-1 ratio, and it wasn't vehicle to cords. It was your level 2s to DC fast, correct?
That was correct, Rick. It was level 2s to DC fast, and it's going to vary based on the operator, based on the route profile, vehicle usage. You're going to have to know your dwell times. You're going to have those sort of route studies to understand what ratio you really need.
Right. And then, for depots and even some of the fleets, I mean, some will have 1-to-1 charger to vehicle ratio, but it's in a depot situation. Not often do you have all your vehicles back. And then it's a little different in medium and heavy duty. And light duty, you may not even have to charge them every day. And I've seen, 5-to-1 cord to vehicle ratio, other way around, vehicle to cord ratio, and then whatever. It really depends upon your fleet and your requirements.
Yeah, I think I made the point. This is where sequential charging could be beneficial. You have high powered fast chargers with multiple dispensers per power cabinet, and you sort of have this ability to charge based on state of charge of the vehicle. So if 3 vehicles plug in, but only one of them is at a 20% state of charge, you prioritize that vehicle over the other 2. And, it's something operators have to understand.
Right. Somebody's commenting that they don't have 480 to support a level 3 currently. So there's, in terms of options for them, we talked about upgrade and the time that may tied to that. There are some solutions out there that will take single phase, and it requires storage. So you're adding some stuff. Have you come across some other solutions, or is that it? It's either an upgrade or some type of, stepwise thing.
So the thing is, like, what's the size of the challenge, right? So,
Right.
And how much space you have. I think that when we talk about like temporary power, maybe more permanent power, it comes down to how many megawatts of power you can house and or generate and house in a shipping container, right? So the trucks and the trailer ratio is typically 1:3, something like that. They like to, have that flexibility. So it's the same size ISO container, right? How many of those do they have spare for room for these kind of alternative solutions on a site? And it came up in conversation yesterday, like they don't have room. They've already provisioned this space for what they need to do for their shipping business, right? And then we start to add in the RTUs and then needing to provision space for, electric shore power for their refrigerated vehicles. So there's a lot of things going on there. I think it plays out, but it's got to be economic. It's got to be realistic.
All right. I don't know if you guys can see the chat. I'm just kind of working my way down. I think we kind of covered this, lead times in terms of upgrading electrical source, and it's gonna vary from location to location. And Paul, you talked about the queue, where who's in ahead of you. That can influence it as well.
Yeah,
So,
one of my favorite ones I do see in here is about vehicle to load, vehicle to grid, vehicle to X. It's going to be important in a variety of settings. It depends on the spare capacity of the vehicles. So in transit, where today conventional vehicles might have a ratio of 10, 15 odd % of vehicles that are idle, maybe they're in for repair, there's something going on there. In electric, we certainly hope that repair ratio buffer is going to be less. So there may be some vehicles available for that, opportunity, call it, but you've got to have the economics behind it, right? Having assets idle, they cannot provide value to V2G unless they're connected, right? So, and stationary behind that meter, if that's where the service is needed. So I'm a big proponent of it, where and how it fits into fleets and their operations, their ability to move power around between vehicle and building, optimize things. Some things are limited there, so you have to be cautious about it. School bus looks great because they're idle all throughout, say, the summer. Moving last mile vans, those things, they need to be out on the road, and heavy duty as well.
I think, Paul, just to add on to the V2G, I think it's definitely part of the conversation. I think folks need to be wary of the fact that they have to have the tariff structure and the utility programs to be able to accept that energy, right? So you don't want to sort of have V2G on your horizon if your utility is not going to let you get credit for that energy with a tariff program or some offering that accepts V2G.
Okay, there's a question regarding this transportable got put in there. I didn't read it that well fast, but off grid. And they mentioned specifically solar, but there are a number of solutions out there. Go ahead, somebody. No, maybe not. But there are a number of solutions, both solar. There's hydrogen. There's a propane solution out there right now. I mean, it's you're with the propane and natural gas, you're generating it in either battery storage or directly doing it. So you're running a genset similar to what you do with your diesel backup, but with an alternative fuel. Hydrogen is an option as well as solar. The portable thing is is the question. Well, these do come in. They're skid mounted, some of them. The portability depends upon the equipment you have. So if you get the special equipment, I guess you can move them. Some of them, it is not an easy task.
Yeah, and you need, I mean, portable, temporary, transportable, all of those kinds of words bring cost, but you again, you have to think about it like, do you lease your facility? Because maybe you don't want to sink that cost into a facility, and it makes even much more sense for you to have a way to take your infrastructure with you. So, we're seeing all sorts of things come in, and you just have to analyze them for what can make sense for you.
Right, and they do tout, I mean, it's one of the benefits of some of these, portable systems, and, you're not tying to the grid. There is no trenching involved, so the permitting kind of goes away. You don't have that extra hurdle in there. So you
Yeah,
can't.
I would say that's a plus. As soon as you start to increase the carbon content of said solutions, you've got a huge negative. So again, realistic, economic, what in the big picture makes sense.
Right.
I
And
love
then,
science projects, but
yeah,
this is about scale, right? So
exactly.
financing will prevail.
All right, this one, actually, maybe you guys can feel this, is high voltage configurations, the 4160.
So I think there are offerings, EVSC offerings that offer the utility transformer integrated into the EVSC hardware. So that is an option, and it is a way to sort of short circuit a little bit, if you can, the utility lead times. 4160 though it is being worked on, but I think there are commercial offerings that are more beneficial that folks can look at for grid connected EVSC hardware.
I don't know if you guys see this one regarding public health and safety and bringing in high power. If there's any information out there to abate concerns or address it.
I mean, obviously have to address safety, right? So some of the things that come into play are the dispenser voltages. So if you go over 1250 DC into a vehicle, the personnel that are around that charging need to actually be trained in that, and you need to protect that others are not able to get into that area that haven't had the same training. Similarly, medium voltage, when it comes on site, needs to be cordoned off in ways, and the staff that work on it, but the setbacks and the security around these kinds of facilities when they do come on the site need additional considerations. I think Jeremy may have some other examples of it, but you got to always look at, like, as you go up, what does that mean in the real world?
Yeah, I was just trying to scan the question really quickly. I'm not too sure I understand the direction, but to touch on the safety aspect, I think one of the things operators have to recognize as their fleets transition, they transition past mechanics to need a journeyman electrician, because these are high voltage systems. You're looking at a vehicle that has a 600 volt system when you step into battery electric, and it starts at 600 and steps up from there in some cases. So I think you are looking for this next generation of operator who is a journeyman electrician, who is trained to handle these voltages, as Paul said. Again, when you get into medium duty and heavy duty fleets and you start looking at the loads 15, 20 MVA, you start to need more electricians perhaps than you need mechanics in the future. So safety is a big concern there. And certainly the industry from a 480 volt standpoint and above has appropriate safety practices and policies to help protect operators and provide the level of training I think the next generation will need.
I'm going to go back. There's some more EV V2G geeky questions in there. The standards that can apply, so if it's IEEE 1547, can apply to the charging station quite easily if it's a DC charger. As soon as you go onto the vehicle and the inversion is taking place there, then you get into gray areas, and you need to provision a site perhaps with additional safety relays around the AC connection to a vehicle. And think of it, this is like solar. The reason why these are there is if the grid is out, we need to be assured that the provisions are there for safety and no chance of backfeed from a vehicle that's providing power back to its charging.
I think we've covered what's out there in the chat. I mean, I'll give you guys any final remarks or something you want to reinforce before we close out today.
I think I like what Paul said the best. I think operators and folks need to have a realistic view of fleet electrification and what it means as they step into medium and heavy duty fleets. Hopefully we've reinforced enough that it is a costly endeavor, but it is one worth taking if you have the right planning and foresight to lay out your transition to electrification.
Just my point is always, if you have multiple sites, treat it as a portfolio and investment over time. And you do need to look at spending some, effort and resource dollar to the due diligence of those sites. And I've come up with a new phrase for it. It's like, be ready so that you can pounce when the opportunity matters, right? So it could be a new tariff comes available, could be a new subsidy, could be vehicle cost goes down and makes parity like it's doing in last mile vans today. And you don't want to be caught off guard not having this foundation in place for your fleet of facilities that support these fleets.
Yeah, that's good. That's some good points. I mean, it's not going to happen overnight. Stepwise is the way to do it. You can't. There's no way you can do it all at once, and you're not going to want to. I mean, you're not going to throw your whole fleet out and start over tomorrow. The long-term planning.
You have to be realistic, and like we got to say a lot. But if you're large enough, by the way, they are, because of they have tens or thousands of vehicles. They have to start doing entire depots at once, otherwise they'll never get the job done. In tandem with their internal combustion vehicle life cycle and asset rotation. So.
Yeah. But no, you guys emphasize planning, due diligence. There's a lot of moving parts here that need to come together. And then Jeremy, you talked about, your electricians may outnumber your mechanics and technicians. And that's the thing you need to pay attention to. It's not a set it and forget it. These things will go down. They're going to need maintenance. They're going to need repair. So you need to plan for that as well. I think, you guys, I appreciate you helping me out today. A lot of knowledge. You guys are out there doing it. And that's what we want to bring to our audience is what happens in the real world here. So I appreciate it. And we are going to go ahead and close it out. Thank you all. Have a good day.
Thank you very much. Appreciate it.
Thank you, Jeremy, Rick, and Paul. Thank you all for joining us this afternoon, and please join us for the next webinar in the series scheduled for April 23rd. Everybody, goodbye and have a great afternoon.
Right. Thank you.
Thank you.
Thank you very much. Appreciate it.
All right. Good day all.